Bonjour, good afternoon, Kwe. McGill University is on land which has long served as a site of meeting and exchange amongst indigenous people, including the Haudenosaunee and the Anishinaabe nations. We acknowledge and thank the diverse indigenous peoples whose presence marks this territory on which peoples of the world now gather, as we do today. So this public lecture is made possible by the contribution of a generous anonymous donor who makes possible several outreach activities in the Below School of Environment. By the way, my name is Frédéric Fabry. I'm director of the Below School of Environment. I forgot to introduce myself. But these opportunities are extremely valuable because they enrich the contribution of university to society and experiences to students. And I think they were sorely missed during the pandemic, and thank God this is over. So we are privileged, well, we hope. We are privileged to have Professor Gernot Wagner as our 2023 Environment Public Lecturer. Gernot is a climate economist and professor at the Columbia Business School. He holds a liberal arts degree and a PhD in political economy and government from Harvard, as well as an MA in economics from Stanford. He's not, however, your usual academic. After a fellowship at the Financial Times, he worked for 11 years at the Environment Defense Fund as economist, senior economist, lead senior economist, and consultant. He then became executive director of the MA program of the new Harvard Solar Geoengineering Research Program. He joined NYU for a few years before moving to the Columbia Business School last year, where he's gone from visiting associate professor to faculty director of the Climate Knowledge Initiative. In addition to writing research papers and plenty of white papers and published policy briefs, he authored and co-authored 5 books, 3 of which in English. One, in 2011, But Will the Planet Notice? On how smart economics can save the world. The second, which is probably going to be more the topic of today, Climate Shock in 2015, on the economic consequences and risks of a harder planet. And Geoengineering the Gamble in 2021 on the benefits and risks of such an approach. Gernot remotely participated in a panel at this year's Montreal Climate Summit. That's how actually I indirectly met him. He was explaining how, for rebate on electricity bills, building owners could let the utility change the setting of your air conditioning remotely to reduce power consumption during peak periods, and how people were using table lamps like you can have on your table, to warm the thermostat to fool the system and still get the needed cooling. This is when I realized that Gernot would not only have interesting perspective on economics and environment, but will also be a fun speaker to have for a public event. Did I mention that he was named by Die Presse the 2022 Austrian of the Year too? In front of a skateboarder and a football coach, nonetheless. So it is with my great pleasure that I give the floor to Gernot Wagner, who will talk to us about climate risks, uncertainties, and opportunities.
Thank you. Thank you. Yeah, Schwarzenegger was not available, so okay, so, well, let me start with, it's great to be here. And frankly, it's amazing to be in a city, maybe the only city, after which a global successful climate treaty, environmental treaty is named. Right, 1989, we're actually solving this problem. And it's the only one at the global level through this sort of policy. Climate, not so much. And, okay, there's a lot of different ways to start this. Let me put it this way. Here is one that happens to involve a Canadian. Actually, here's a real pop quiz. So I think everybody knows the now, I believe, 19-year-old on the left. The 78-year-old on the right. Václav Smil. Bill Gates' favorite energy policy analyst or so Václav Smil claims on his book jackets. One is, right, one is the activist. The one pushing us, the one, demonstrating, protesting, and so on. 2 million Twitter followers, 4 million last I checked, and so on. Amazing. One on the right is sort of, the realist, the naysayer, the, well, wouldn't it be nice, but. Same interviewer, same graphic designer, New York Times Magazine, Sunday interview. A couple years apart. To me, at least, they're saying the exact same thing. The difference? Václav Smil on the right, quite literally on the political right as well, is basically saying, I'm not talking about how the world could or should be. I'm talking about how the world is. Greta? I'm not talking about how the world is. It's a mess. I'd like to focus on how it could or should be. I'm trying to do my best to change things. But when you actually dig down, right, like the fact base, the how many kilowatt hours of a certain type of electricity, it's the same data. By the way, the best data comes from an oil company, BP. Sort of the thing that we all go to for the easily downloadable stats to then either look at how the world is on the one hand or draw lines, extrapolate how the world could or should be. Well, here's the problem. One of them, just to be clear, not the only problem. But right, we just emit of that stuff, CO2. All greenhouse gases, of course, and then there's lots of other problems out there too. But let's focus on this problem. And by the way, we know what the solution is. And by the way, when I say we know what the solution is, that's already a pretty loaded statement, because when you ask 200 MIT graduate students how to solve this, you basically give them the same graph in an infamous experiment. They just draw a straight line, stabilize CO2 emissions in the atmosphere. Right? No, that's not the solution. If the bathtub is overflowing, you don't make sure that the water going in doesn't increase second after second, CO2 year after year. You try to get the water down to 0 and fiddle with the outflow. But frankly, that solution in this highly scientific rendering been known for at least the 20 years I've been sort of conscious of how these models look like and how they work. Every climate economy model on the planet says by now, mid-century, plus minus 30 years, by the way, minus 30, you sort of know where we stand, got to get this down to 0. That is the solution to climate change. Now, there's lots of permutations of this. There's lots of things to say. There is not just mitigation, it's adaptation, it's geoengineering potentially. We're definitely at a stage where we need to suck CO2 back out of thin air. Right? Trees do that naturally. We've got to do it artificially too, because frankly, well, hottest September in recorded history. By the way, twice as high a record as the prior record. Right? This thing isn't looking any better these days. But the solution, no matter what you think of geoengineering or any of these other topics, CO2 has got to come down to 0 or below 0 to get back to, closer back to where we came from. Okay, so I am an economist, which means I've got to translate all of this into dollars. US, Canadian, doesn't matter, it would be false precision to look at the difference in this case. But also, we need to look at the stuff we don't know. Right? What we know is bad enough. The risks, the uncertainties, the unknowns make it potentially much, much worse. Okay, dollars. 200. Now I'm nothing but prepared for this talk. Look at the difference here. I didn't bother translating it into Canadian dollars because, yes, that would be false precision. It's like approximately those couple $100 per ton of CO2 that we know that this problem is costing us. Which, by the way, is a little bit of a new insight. Not too long ago, we were talking about $50 per ton of CO2. Obama era, US social cost of carbon calculations, that, by the way, by then were sort of derailed as, sailed as, oh, this is, the Democrat in the White House, of course, right? The real number needs to be lower. Well, by now we have another Democrat in the White House. There was sort of an interregnum in between when that number went down to like $1 to $7, fiddling with assumptions. By now, basically, more or less the same logic going into the calculation, just redoing it with newer empirical results. And using a better estimate, a more well-supported estimate of the discount rate, how much the future matters, ought to matter to us. An ethical choice up to a point. When you fiddle with those, and no, I'm not asking you to read this whole table, but yeah, there's this number that comes out of this process, interagency process in the US government, where you can pick a lot of numbers, turns out, by the way, and every one of them would be false precision, but $200 is basically what I would call the bare minimum, a partial estimate of the full social cost of each ton of CO2 emitted into the atmosphere today. Okay. What does this show? It's what statisticians would call a PDF. Not what Adobe gives us, right, but a probability density function. Last very technical term I will use here, but this is instructive, right? So yeah, you can pick a number, the most likely, the average, the mean, and so on. But then look at the tail. We can cut things off on the left, right? Adding CO2 isn't going to decrease temperatures. There's very little uncertainty. There's very little room for uncertainty on the left. On the right, not quite as lucky. So yes, there's this tail, fat tail, arguably, where, yeah, we can give you a number. We can't exclude much, much higher numbers per ton of CO2. And yes, there's some nerdy explanations for why that's the case. There's a paper for every one of these. There's many, many papers for every one of these. Won't go into the details there, but just one of them, tipping points. Right? Climatic tipping points, the sort of dramatic thing that can go wrong. And by the way, not just could hypothetically, but in some sense, we know that, right, the Amazon forest would disappear eventually if we keep pumping CO2 into the atmosphere, or the West Antarctic ice sheet is going to collapse. Right? It's not a question of if that happens. It's when, how fast, how large are the uncertainties, what are the true impacts, right? Lots of sort of unknowns, unknowables even around it, but the fact that these things are going to happen, unless we change course, it's basically a given. Well, again, sorry, economist here. Well, what happens when you translate that into dollars and cents? Dollars, cents will be false precision. All you need to do is squint at this graph. This is the impact, the economic impact, per ton of CO2 of those climatic tipping points. West Antarctic ice sheet, Gulf Stream, Amazon dieback, methane in Siberia, and so on and so forth. There's an estimate we can give you. By the way, it's like 25 to 50% higher for that cost of carbon on average. Mean, median, average. Then look at the tail. We can't exclude that social cost estimate, just because of those tipping points, would more than double. In fact, there's a 1 in 10 chance, there's a 10% chance that just those tipping points alone would mean the social cost of carbon, remember $200, would double. Now, I'm not going to tell you the number ought to be 400. We don't know. But at the very least, right, this is not approximately $200. It's a partial estimate, a lower bound, a lowercase conservative estimate. It's basically, okay, at the very least, that's where we've got to go. Okay, what does that mean? In English. German accent in English, but English nonetheless. Average North American emits how much CO2? You can phone a friend for the answer. Approximately? Anyone? 20 is, yeah, actually by now it's gone down. Well, we started at 20, but now we are down to 16. Second friend, any better answer? So we're like 16 tons of CO2, right? Average European, by the way, emits about 8. So as a dual citizen, I get 24. But, right, so every one of these tons causes that $200 worth of damage, at least. And frankly, right, there's sort of two ways of looking at this now. And one is to basically say, wait, that's it? I thought climate was a real problem. Right, so $200, let's call it 20 tons. Let's run with that. Right, 20 tons of average emissions, $4,000 a year to basically solve the world's largest public policy problem, most global, most long-term, most uncertain, most irreversible? I mean, yeah, it's a lot of money, yes. By the way, it's sort of 8 to 10% of global GDP, total economic output. But again, $4,000-ish, maybe a lower bound, but still, that's not a lot of money to basically solve climate change, which is what that is the answer to, right? It's sort of, how much should we pay per ton of CO2 today to internalize the entire negative externality, those negative spillovers, that ton of CO2 causes over its lifetime in the atmosphere? That's the answer. Oh, that's the question. Here's the answer. Right? Or, of course, right, the opposite would be to say, wait, $4,000 for everyone. Right? All 8 billion of us, by the way. For the, rich New Yorker, right? Doable, possibly. For the average global citizen, who, by the way, emits a lot less. But still. On the other hand, yes, there's a number one can calculate. We can debate this number. We can have philosophical discussions about it. We can write papers about this and sort of intellectual masturbation, right? Sort of paper on top of paper. Well, one gets 200. Actually, what about 250? Maybe 400. But you overestimate certain things. The optimal number might be lower. Isn't it so cheap now to install solar power that number should come down? There must be an upper bound here for this number, for example. Right? Yes to all of the above. But at the end of the day, yeah, economists, climate economists can put a number to this question and say, if we were to, all of us, not just individuals, of course, all of us collectively, by policy, pay those $200 per ton of CO2, we might be at a lower bound, but it would do quite a bit to solve this problem. So what's the solution? Right, this is where the economist would say, well, wouldn't it be nice if we had a global government, one global policy, one global price? Newsflash, we don't live in that world. Right, there's no global carbon tax. There's the Swedes who tax themselves something like $130 per ton of CO2 and have been for a while. Their carbon tax was lower back then, started in 1991, long before the rest of us. European Union, there's 400 million of them, us, I guess. If you live in Europe, you pay 100 euros-ish per ton of CO2 for about half the CO2 emitted in Europe. Right? Not 100%, not all of it. Same order of magnitude. Approximate solution. By the way, the other Austro-American I mentioned, the guy who showed up with a few more steroids in his suitcase when he came over, he signed the law into place in California, like 7th, 8th largest economy on the planet on its own, 40 million Americans. Cap and trade system, emissions trading, price per ton of CO2. By now it's about $25, $30 per ton of CO2. Arguably an order of magnitude too low. But then, by the way, there are all these other policies in California banning internal combustion engines sooner rather than later, and so on and so forth. Subsidies for the good stuff that add up to quite a bit more, frankly, than whatever the emissions trading price is. Or in other words, of course it is a policy mix, right? It's not just one thing. Duh. No one silver bullet technical solution, no one silver bullet policy solution either. Now, it's also not the only externality. Here's just one sort of local example, local in my case. By the way, not all of New York City. Lower Manhattan, right, sort of what the rest of us think of New York. Every individual car, by the way, not car over its lifetime or something, like one trip, one car trip into Manhattan below 60th Street. For that one trip, at least $150 worth of negative congestion externality. Forget CO2. Forget anything else, right? Like sort of, you know, every once in a while there's a crash and so, none of that. Just congestion. Just the fact that adding one more car, right, delays everybody else. And yes, there's an average wage per hour of delay and so on and so forth, right? Sort of this autistic calculation. Every one of these trips, $150 of, at least $150 of negative congestion externality. New York City, next year, spring of 24, is going to get a congestion fee. Great. I think the highest number being talked about is $23, by the way. Let's say 15 is more realistic. Right? A tenth of the actual overall cost. You're clearly not solving this, but actually here's the question. If we were to charge the $150 per trip to the city, which is sort of, you know, the economist's favorite answer, what does that do? I mean, first of all, it's just, you know, politically impossible. Let's just put it that way. Right? There's 8 million New Yorkers. By the way, like 1 million or so live in the congestion zone, right? So even the 7 million other New Yorkers, right, who, by the way, don't drive, right? Very few of them do. 90% without a car, 60% or so without a driver's license. But obviously, right, it also affects some New Yorkers themselves. Well, there's like 20 million people who claim they are New Yorkers. There's 12 million living in the burbs, right, who claim that they are New Yorkers, more or less. Some are proud enough to tell you which suburb they live in, but you know, they're all New Yorkers, the major metropolitan area. If you were to charge them $150 per trip, you might as well ban cars. You might as well call this infinity, right, which for the mathematicians in the room, This is infinitely less than infinity. I do understand the math here. But practically speaking, if you were to charge $150 per trip during peak travel times, and frankly it doesn't matter when, you might as well say, let's just figure out how to pedestrianize Broadway or Fifth Avenue and put bike lanes and bus lanes and yes, one emergency lane for the truck garbage pickup and emergency vehicles or something. But let's just ban private vehicles at this level, right? Or in other words, much like this, by the way, right? $200 per ton of CO2 overnight, the 150 per car trip, or any of these other externalities that basically have a feature like this that are just pretty darn large overall. When you think about it, at the end of the day, the right policy often wouldn't be to say, let's price it at the right amount and be done with it. The right policy very, very often is to say, it's got to be something else. Can't just be what the economist says is the optimal fee, but let's take the real step. Let's invest in bus lanes and bike paths and so on and so forth, provide alternatives, make alternatives cheaper in the all-encompassing sense of the term. And while we are at it, internalize this negative externality. I just broke the clicker. Sorry. Here we go. Sorry about that. Self-inflicted wound. Let's just price this externality, figure out how to get this massive cost internalized in this all-encompassing sense of the term, and at the same time, realize this, that yeah, we can calculate the stuff we can calculate, duh. And then the stuff we can't calculate might make it a lot worse. Probably does make it a lot worse. Because climate policy at the end is risk management, is insurance. Okay. Thus ends the depressing part of this evening. Early evening. Let's shift gears. Right, what's the flip side of this? How do we get ourselves out of this? What do we do? And frankly, actually here's the real news quiz now. Who knows what this is? Who's seen this before? Few. Good. It's been around for a while. This is actually, for those in the know, it's the McKinsey MAC, the marginal abatement cost curve, which if you read the fine print, is from like 2009 or so. Actually, even the subtitle up there, 2009. Right? It's been around for a while. This is version 2, so 15 years and still going strong. Lining up intervention, technology after technology, of stuff that's going to solve climate change, cut CO2 emissions. This is a global version, hence the euros here, the top left. How much does it cost per ton of CO2? And how much CO2 can we get rid of? How much are we emitting globally right now? Plus, minus? Approximately those 35 to 40. Depends on what you count. Fossil-based CO2 emissions. So basically, here's a management consultancy that has been telling us for 15 years that we can solve it all, literally, just get rid of all of it, at costs below 50 euros, 50 bucks. Again, false precision to convert the euros into dollars here. 50 plus minus. And by the way, most of it is much cheaper. A third of it pays for itself. the left-hand side of the McKinsey marginal abatement cost curve, where the calculation tells us you get paid to cut CO2 emissions. Right? A third of the problem, the very left, switch from incandescent light bulbs to LEDs, which nobody needs to tell us anymore. In the US, it was George W. Bush, well-known lefty, who signed this law into place that essentially set a standard. It didn't ban incandescents directly, but set a standard that was getting tighter and tighter. By 2020, incandescents, the ones from back then, were basically illegal, outlawed, because that standard was so tight as to no longer allow stores to carry incandescent light bulbs. But the rest of us who were around back then would call it just light bulbs. We literally made light bulbs illegal. Europe did the same. Plenty of other places followed suit. So, no, just because it paid for itself didn't solve the problem. It took policy to say, okay, the smart thing to do is to choose the kind of bulb that pays for itself. And by the way, let's not put the burden on you. Right? Let's, quote unquote, if you depend on your political leaning, right, take away that freedom to choose from you. Or frankly, I would say, give me back my freedom. Right? I can walk into the store and say, wait, I don't need to do this calculation every time I buy a light bulb. Some PhD in the employ of the Department of Energy did that for me and figured out that it's better to use the more efficient LED, where 99% of the power goes to light as opposed to 90% of the incandescent goes to heat. I just buy the right thing because the other thing isn't available. I can FedEx it in from somewhere else, right, if I really care. But most decisions, most days, I don't need to bother. And example after example like this, right, basically, if it's been solved, it was policy. It was some of us basically, banning it, more or less, pricing that car trip into New York at $150 per trip, equivalent, to basically say, look, there is a better way to do this, to organize ourselves. Let's figure out how not to do the stupid thing. Right? Insulation retrofits in commercial buildings. The second sliver that's called out here on the bottom. Right? Same idea. Yeah, it will pay for itself. And by the way, commercial buildings, right? These are companies. They have CFOs. They have people whose job it is to save money for their company. And they apparently couldn't figure it out. Or actually put differently, and maybe this is sort of the, it's somewhat of a joke, I guess, but this is McKinsey telling us these things. They're a management consultancy. Right? The usual story of, oh, everyone is doing everything optimally already, you're taking away freedom when you tell them what to do, their entire business wouldn't exist. I teach at the business school. Why do you need to educate people in how to run businesses if everything is already running optimally to begin with? Of course there are inefficiencies to be teased out. Of course there are new technologies to be deployed where we need policies that basically tell people to deploy them in whichever way, shape, or form that policy might do so. And yes, we're still staring at stuff like this. This is the IPCC report, right? Different orientation, more or less the same information. Slightly nicer color scheme. Zoom in. Yep, you care about climate change, you work on energy, and you're not working on wind and solar, you're doing something wrong. Right? Blue pays for itself. The stuff that's below the x-axis in the McKinsey graph. This is the IPCC rendering by 2030. Yeah, sure, fiddle around with all the other stuff. And by the way, please do. Let's do lots of R&D and so on and so forth. And there's some other blues there too that already pay for themselves. But again, look at the big opportunity. And when you go through this, you know, there are no more light bulbs to be solved because we've solved it. This is buildings. Yes, there are opportunities, retrofit opportunities, heat pumps and so on, that, yes, pay for themselves. Buildings intimately tied to how we get from building to building, transport. Look at all the blues. One thing that's not blue, biofuels. Right, corn ethanol, we subsidize up the wazoo. Everything else, electric vehicles, absolute no-brainer to go that route. Of course it is. 5 times more efficient than the internal combustion engine running on whatever biofuel you would want, or you could have, even the most ideal one. All these things pay for themselves. Yes, that's where the opportunity is. What's the barrier? Back to McKinsey. Way back when, same data, different rendering. There are massive upfront costs for some of these. Right? Transport, where basically everything pays for itself. Yeah, it does. It did back then too. It's below the x-axis. You save money year after year after year. How do you get there? Right? They even had to break the cardinal rule of how to draw these graphs, right? They didn't put the bubble all the way over here because it's just so darn expensive to put up the upfront cost to then take advantage of these opportunities. Meanwhile, should we as a society, right, insulate our buildings better? Get rid of the gas furnace and put in heat pumps and so on and so forth? Yes, of course. How do we get there? Policy. Okay, couple more numbers. What does it all add up to? Right, the sort of the trillions of dollars of costs of not acting. What are the investments? What are the costs of acting, of actually doing something about it? Another McKinsey report. Actually, any McKinseyites here? Anti-McKinseyites, okay. That's fine. I worked for BCG for a year, so, you know, I hate them too. Last year, early last year, McKinsey report. $9.2 trillion per year for the next 30 years in order to turn this climate ship around. And I can only imagine how they got there. I mean, sort of obvious, right? So they write the report, right? Some earnest consultants do the math. Somebody paints the slides, and then they put it in a report. And then the marketing department of McKinsey tries to figure out how to draw attention to this thing. And how do you draw attention to these reports? You come up with a large number. Massive. 10 trillion bucks a year, 9.2 trillion bucks, right? False precision there, but okay. Order of magnitude, 10 trillion in order to solve climate change. Massive, massive number. Now, of course, the flip side of that is massive opportunity, sure, right? Hire us, we will tell you how to do it. There's part of this too. But still, right, the emphasis is on these large numbers. And by the way, here's a fun little bubble chart that will tell you some more details. And yes, it took one of us consultants quite a lot of time to generate this. By the way, what this shows is that, of course, the impacts are unequal. Of course, the opportunities are unequal globally, right? Some of us globally who would benefit, plenty of others, right? Oil exporting nations, the Middle East, host of the next UN climate meetings next month, who would clearly get hurt quite a bit if we were to do this transition fast and so on. Right? Well, here's a slightly different rendering of the exact same information. And yes, I'm biased on this one. This was my column based on the McKinsey report. Same data, different color scheme. XBCG, so it had to be green, but no, it was a Bloomberg column. Okay. I'm rendering the exact same data. Black is the current path. Current policies, yeah, we're going to be investing more and more over time, which is sort of the natural thing to do. And by the way, we're not cutting emissions. Not by a long shot. Not soon enough, not quickly enough. The green are those McKinsey numbers. Add it all up. Current policies cost $250 trillion over those 30 years. The green stuff, $275 trillion. So yeah, 275 divided by 30, and you get to this massive number, 9.2 trillion. What actually matters? Well, two things. Is there enough money in the world to solve this problem? Yes, there is. This is not, right, oh my God, this unsolvable catastrophe, might as well not even try. Second, difference is 25 trillion bucks over 30 years. You know, I can't do this myself. I'd have to sell a couple more books. But this is less than $1 trillion a year, globally. Globally. Not pocket change, but eminently doable, especially, of course, compared to, frankly, the sort of investments that are actually happening. Right? So the US Inflation Reduction Act, $1 trillion, turns out to be over 10 years. The trillion-ish, plus minus a few hundred million, 300 billion, sorry. So no, that alone doesn't do it. Well, the US is also only 25% of global economy, 4% of global population, by the way. All right? A bit of European money, a bit of Canadian money, a bit of Chinese money, lots of Chinese money, and so on and so forth. $1 trillion a year? Now, there are lots of problems, right? There are sort of questions in how to actually deploy this. How do you unleash the sort of thing that we all think is necessary? How do you, by the way, get the policies right? Right, we're about to start subsidizing green hydrogen. Sounds pretty good. Let's do it. Right, you burn hydrogen, all that comes out on the other end is water. Okay, great, fine, cool, let's do it. Well, if we don't get those rules right for what qualifies for the tax credit, remember when I made fun of biofuels before, corn ethanol? Well, we are subsidizing corn ethanol, and we are increasing emissions as a result of that subsidy. And we are never going to get rid of it because presidential primaries in the US start in Iowa, and corn dogs are delicious. So yes, there are questions. Not everything is, right, by default moving in the right direction. But if we get the rules right, that would unleash hundreds of billions of dollars just for this stuff. Small part of the actual solution in the right direction. Actually, I need to apologize right now in advance because I promised sort of the nerdy econ graph before was the last one. So here's an even more unreadable one. All you need to do is look at the title of this thing. By the way, a close colleague of mine in the econ division at Columbia Business School, Connor Walsh, is a co-author of this paper. Clean growth. If you squint at some of these lines, yes, it's the US Inflation Reduction Act. Canadian GDP in 2030, European GDP in 2030, GDP, by the way, in any other country where they have data for, in 2030, is higher because of the US Inflation Reduction Act, not because of all the policies in Europe or in Canada or anywhere else. US Inflation Reduction Act subsidizes the clean, green, lean, mean stuff in the US. Productivity spillovers make all of us better at installing solar panels and so on and so forth, make solar panels cheaper? Well, productivity basically means doing more with less. Magic sauce. So GDP in the sort of the most narrow-minded calculation, right? This is not caring about climate change, right? We should be doing this because we're doing the right thing, because climate change is costly and so on. No, just economic output, nothing else. Goes up, not just in the US, where you would expect it to go up, all over the world because of the US Inflation Reduction Act. Most sort of standard, narrow-minded, if you will, macroeconomic calculation you can imagine. And yes, the thing is called clean growth for good reason. And by the way, don't take it from us eggheads in economics departments who, you know, if we knew how to do this, we wouldn't be teaching, we would actually be doing. This is the world's largest asset manager. Trillions of dollars under management. Same conclusion. Yeah, it costs money. No, it's not happening automatically. But actually, even the very existence of this report, right? So why would somebody whose job it is to manage a lot of money, not their own, other people's money, why would they even bother putting out a report like this? Right? It's not their job. It's our money, our pension money, pension funds and so on, invested with them. They're just supposed to be maximizing returns for us. That's what we're paying them for. Right? Why would they put out reports that could come out of an IPCC report if it weren't for the different color scheme of the BlackRock folks? Right? Why would they even bother? Well, actually, here's my interpretation at least. This is forecast on the one hand. It is target on the other. Right? Forecast is basically, this is how things are going to go. So, you know, let's invest in order to make sure that we profit from that new world. And then putting out the report basically tells the rest of us, hey, don't trust us, you know, we know what we are doing, give us your money, we will manage it for you. The target is, yeah, them putting out a report actually has a little bit of influence, turns out. Right? The rest of us might look at this and say, oh, interesting. World's largest asset manager is thinking these dimensions. Maybe I should be too with my $500 retirement fund. Right? So yes, of course, it's about nudging in the right direction as well. I made fun of BCG. Sorry, I made fun of McKinsey before. Let me make fun of BCG. This is the global chair of BCG, Rich Lesser, at Columbia Business School, giving a talk. So by the way, when he gives a talk, he shows up with 3 slides, not 90, right? Because his day job is basically coming in to make the final sale, right, of this case, let's say. Pay us $1 million a week. We send a few 22-year-olds with too many frequent flyer miles and rings under their eyes to paint slides for you. Well, here's one slide. Competitive advantage through going green. The fine print, which you can't see for 2 reasons. A, it would be too small, and B, it's covered by the zoom line here. But when you actually look at the fine print, our assumption for how you as a company, by hiring us, will get competitive advantage through going green, we assume a global carbon price by 2030 of 100 euros per ton of CO2. BCG analysis. Same thing. Forecast on the one hand, right? If it were just wishful thinking, it wouldn't do much. If it were literally just Greta, it wouldn't actually get us there, right? Or maybe it will because, well, Shell scenario planning, late 90s. Shell famous for the sort of 3 scenarios, right? The most ambitious, the sort of realistic one, and the conservative one. Shell in the late 90s as a sort of the craziest out there scenario. What about a youth-led uprising by 2020, making us, big oil, go the way of tobacco. Shell predicted Greta before Greta was born. We're back to this. Maybe it's both. Right? If the guy in the suit shows up and says, wait, 100 euros per ton of CO2, not just forecast, not just target. Of course it's both. It always is both. It's the mix of these two. It's the combination. Or for that matter, it's not one versus the other. Of course it is both. It always is. It always must be. Right? I can stand here and boast about having spent a lot of money decarbonizing our 70 square meters in Lower Manhattan. Cool. Good job. Solve climate change? Nope. Street cred? Sure. Moral something? Maybe. Can show you pictures of my kids. I can show you more pictures of the kids. I can tell you how when you force the 9-year-old to make dinner for you, sometimes dinner will be pancakes. Yes, of course, right? There are better ways to organize yourselves as society. This is east coast of the US. There's New York City up there, top right. This green thing. You zoom in and focus on transport. You know why. Right? Living on the land, off the land, fantastic. Every environmentalist dream, right? Out there, top left. New York City itself, any city, by the way. I don't have the local numbers, but I can only imagine if you live within walking distance of your work, of McGill, yes, your transport emissions might be very, very low. Where do emissions go up? Well, the in-between. Right? Enough wealth because you're close to the city, and the 6-bedroom, single-family colonial because, well, what else are you going to do with your money? And by the way, of course you drive back to the city because that's where the jobs are, right? Back to the 20 million New Yorkers. 8 million actually live in New York. And, well, there are different ways of taking this, right? So there is basically the, look, all of us care about this stuff, turns out, when we have the choice. We are all for the, 15-minute city walkable urbanism. Why would you spend more time wasting time on vacation? Right? Not the best example, by the way, that is real. That's not a rendering. That thing actually exists. Floating Petri dish. This is North America's second largest public transport network. You know where that is? The mouse might give it away. Top right. It's Disney World, Florida. The parking lot, by the way, is as big as the thing itself, because to get there, of course, you drive. By now, actually, there is one train line, amazing new invention. Figured out how to run trains in Florida. But once you are there, yes, you have the largest public transit network, the second largest, New York City is first, in North America. Why? Because it's your vacation. You really want to be stuck in traffic doing the same thing that you do any other day of the week? No. When you have the choice, you spend extra, by the way, of course, to have the hotel inside to have a direct access. And people do. Why would you? Why wouldn't you? Right? If you're there with a 6-year-old trying to enjoy the rides, you're not going to try to find the car at the end of every night. You're trying to have pizza with the kid. Inside, with access. Let me end on this. Remember this website? Before that guy started destroying it? This was one of his employees. Andre Karpathy, the head of Tesla AI at the time, April last year. Now he works for OpenAI. Different problem, different topic. So here's the guy who is literally chiefly responsible for the ultimate mobility technofix, turning EVs into AVs, electric vehicles into autonomous vehicles. Right? The guy in charge of the Tesla AI team. Turns out when he goes on European vacation, he figures out that there's a better way to organize ourselves than whatever that thing is between San Francisco and San Jose on the West Coast. Right? I mentioned there's 20 million New Yorkers, as in 8 million New Yorkers, 20 million claim they're New Yorkers. How many people live in San Francisco? Bless you. 600,000. How many live in the Bay Area? 20 million. There's like 19.4 million Bourbonites and 600,000 people who live in the one city where it started, arguably, right? And of course, by now there's other cities too, with sort of walkable, you know, at least strip mall in the middle. Single family homes around, right? And then there's the guy who spent his entire life there, adult life there, living in one of these overpriced single family homes in the middle of nowhere. And yeah, then he goes on European vacation and figures out that there is a better way to organize ourselves as society. Or in other words, no, it's not just technology, of course not, can't be. It's technology and behavior, it's technology and policy. It's all of the above, it must be all of the above. Or put differently, it must be the right mix between these two, right? It's technology allowing us to do certain things, yes, of course. Let's invest in the new shiny objects. But at the end of the day, of course it's about, well, deploy the sort of technology that currently is available. Solar PV, cheapest form of electricity in history, according to the International Energy Agency. 3 years ago by now, by the way. It's only gotten cheaper since. Yes, of course. What's the new shiny object? Well, I mentioned hydrogen before, right? So, 40 years ago, when Jimmy Carter put solar panels on the roof of the White House, they were 100 times more expensive than today. Reagan came in, 5 years later, those solar panels were gone. Nobody takes solar panels off roofs anymore. They are the cheapest form. Yes. Meanwhile, now we have this new shiny object, right? Like fusion is the latest, right? We figured out how to actually generate some electricity once. And yes, there's plenty of potential, sure. And maybe that's the eventual solution down the line, of course, maybe, hopefully. Right? Cheap, endless, carbon-free electricity and so on and so forth. Sure, let's go for it. Meanwhile, we have the technologies today, we have the better ways of organizing ourselves, and so on and so forth, that, yes, the name of the game is to actually get on with it. This kid by now is 12. My kid, by the way. So yes, there's 5 of my babies on this slide. 5 of the 6 of them. We had the same conversations back then. What's different now? Honestly, it's the optimism. Honestly, it's basically having solar PV, which 40 years ago was 100 times as expensive. 10 years ago, 10 times as expensive as today. And it's only going to get cheaper. There's no other way. Right? You're not going to unlearn. Solar is a technology. Right? Technologies get cheaper, better over time. If it didn't get better, right, we would just use last year's technology. Well, it turns out we don't unlearn. We get better at this stuff. Oil, coal, gas, commodities. Right? Every decade, actually every decade, ever since the dawn of the fossil fuel age, right? Some surprise event. Whoops, guy in Kremlin blows fuse, February 24th last year. 10x gas prices. in Europe in this case, but global reverberations, of course. Right? That's what commodities do. Solar PV, by the way, last year, yes, prices increased as well around that time because demand went up by so much. Solar PV was 20% more expensive last year than the year before. So doesn't that mean that there's an exception to this? It always gets cheaper? Well, no. First and last economic lesson here this evening. It's the relative prices that matter, right? Not the absolute ones. It's always about the comparison. Fossil fuel prices increased by like 200%. Solar increased by 20%. Relatively speaking, even last year, when that new technology became more expensive, relatively speaking, it was cheaper. And by the way, it decreased in price by more than ever before, that there is really no excuse these days. Thank you.